origami. I would take duct tape and make things out of them. I didn't actually know about engineering because nobody in my family was an engineer. And so I didn't really think about it until I went to college. And then when I went to college, I saw engineers for the first time and was like, wow, this is so cool. It's basically just making stuff, which for me is what I love about art as well. It's making stuff. And in particular, I fell in love with product design. So mechanical engineering is actually a really huge field. Like engineering in general is about how you solve problems using math and science. And product design specifically is about how you can design products that people use. So like the computer that I'm talking to you on right now is a product that was designed by a bunch of engineers. Some software engineers who think about the coding, some electronics engineers who think about electronics, as well as product designers and mechanical engineers who think about, okay, how are we going to like put this all into some physical object like a computer? So my first product design class, we actually worked on making something that could take milk and then dry it up into powdered milk for farmers out in the country who didn't always have access to electricity. So if you don't have a place to put the milk, if you don't have a refrigerator, the milk will go bad, and we don't want that. And so I fell in love with product design. And the reason I fell in love with it is it was sort of this combination of again, like my love of making stuff, of solving problems, of thinking about, okay, how are we going to make this thing that can dry up milk just by using our creativity, using some math, some science. And a lot of it is just about like building things and trying things and seeing what works and seeing what doesn't. And to get all the way to this final version, we went through a lot of other versions. That's just a couple of pictures of some of the other ones. So I mentioned I also like to combine art with things. And so as I kind of in school kept taking more product design classes, I found ways to kind of combine the art as well. So, you know, this is a product we designed for a class that is something that it's like if you only have one shirt and you don't want to like do laundry for just one shirt, it's something where you can just put that one shirt in and it'll make it less wrinkled and make it smell nice. It won't be like 100% clean if it was covered in mud. But, you know, sometimes you just wear the one shirt and you're like, oh, this is a little dirty, but it's not worth washing. But you can already see that it kind of looks more artistic than the other one. And so, again, it's sort of this process where we were starting to think both about like, how is it going to look from the artistic side, but also how is it going to work from the engineering side? And so if you look at the bottom corner there, those are all drawings of us trying to brainstorm, like, how are we going to make this thing? And so we use sort of our creativity as well as the math and the science to make these things. And then again, a lot of testing and trying things. So this is another one where, again, now you really see the art and the engineering come together. And this was basically for a science fiction project where we just had to make something that was science fiction themed. And my team wanted to make a really cool door. And so we illustrated ideas ahead of time. And so in some ways it looks like an art project, you know, it's got all these cool lights, it's got, you know, this really cool visual, but if I show you the back, like that's all engineering there. You know, we had to think about how is it actually going to move? We had to think about the electronics. It uses air power actually to move. So after I graduated, I really wanted to keep doing things that combined art and engineering and product design. And so I worked at a place called First Robotics, and they're a nonprofit that runs robotics competitions to get kids interested in engineering and science. I think they actually have a bunch of teams in India if you guys are interested in looking into it. So I was working at the high school level one. And so the students actually build the robots. My job as an engineer and an artist there was to help design the games that the robots are playing. And so we have these really big fields. And as an engineer, I had to think about like, okay, how is this going to be strong enough that when a robot runs into it, it's not going to break? How is it going to automatically score like all these little balls? They're going to come through and we need a way to automatically score them. And that's starting to actually get into robotics at that point, because when a machine is doing things automatically, that's robotics. And we'll talk a little bit more about that. But in addition, First Robotics, they wanted all the games to have a theme so that they're kind of more fun and they tell a story. And so I got really lucky, and I also got to do the art for all of them, which was super lucky because a lot of the times if you get an engineering job, you're mostly just doing engineering. And in my case, I got to think about how, like, okay, how are we going to build this? How is it going to move? All the like science and engineering. But I also got to think about, okay, but how is it going to look like? So these were the games that I worked on. And this one's Star Wars themes for anyone excited about Star Wars. I did not build R2-D2, unfortunately. Whoops. But again, like, so the engineering side was a lot of thinking about like, how is this going to work? Where are the motors going to go? Where are the sensors going to go? A lot of it is designed on the computer actually, and then you go and you build it on the machines. And there's a lot of math just thinking about the physics of it. So like, you know, if you have, you know, a ball that weighs this much, how much, you know, where's the geometry of this need to be like? What material do I need to make it out of? And at the same time, like I said, there's also a lot of art. So, okay, you know, now we can make it work, but how do we actually make it look like what, you know, we want it to represent? So this is actually a video from one of the first robotics games. I won't play through the whole thing, just the beginning, but just to give you a sense of what it actually looks like in action. If it's going to load. Oh no.
It's just starting their trade now. 5 more as the Blue Alliance unloads once again on the high efficiency boiler. Blue Alliance.
So these robots are actually all built by high school students. And they work together as teams, and in 6 weeks they build these robots that can do all these things like shoot balls and move around and like pick up objects and things like that. So they're really cool robots, in my opinion. So like I said, I always love combining engineering and art, but I started moving more and more into robotics and started moving more into engineering education as well. I moved around a lot because this was when I was in the US, and then we moved to Ireland. And when I was in Ireland, I worked for a more traditional robotics company. So this one you can see is not quite as artistic, but it's very functional. So this one is designed to, let's see if that's loading. And I should add also, all of these projects I'm doing, they're all done in a team. Like, it's really hard for one engineer to design all of these things. So we work together as teams. These ones pick up these storage racks in factories and move them around. That way the worker doesn't have to like walk down the hallway every single time and find something. The robot just brings it to them. So that was all really fun. And so that's what I did in Ireland. And then we moved again. And at that point, I realized that I didn't want to work for a company again, just because I kept moving. And so it's going to be easier if I started working for myself. And that kind of gave me the chance to come back to what I really love, which is combining art and engineering and education. And so there's a couple things that I was working on as side projects. So I mentioned combining art and engineering. So I wrote a book that combines, you know, engineering with storytelling as well. And now I'm working on a comic book as well that also combines engineering and art and storytelling. And all of this is sort of how, you know, I got into paper robots as well. Basically, when lockdown happened, I didn't have access, like all these other robots you saw, they were made out of metal, they were made out of plastic, you know, even the stuff that wasn't robotics, like, you know, this stuff, a lot of this requires machinery to make. But in lockdown, I didn't have any of that. I had a little bit of electronics at home, like some very small things, and I had a lot of paper. So I said, okay, what can I do that combines robotics with the materials I have? And I also turned my artist brain on and started getting interested in how you can use paper robots, especially because that's something that, you know, I mentioned I really care about education. That's something anybody can make. You can, if you can get the electronics, which, you know, that you might need to get help from your school or from your parents. but that's something that anybody can make at school, at home, without needing a lot of special machinery. So I will actually have a video, but also show you the one that I put in. So this is one of them. This one's like a little dragon. And again, they're all made out of paper. They have basically really simple motors. And this one, when you pet it, you can see its tail wags. And so it's actually connected to this thing, which is basically like a really small computer. It's called a microbit, and there's a couple different, so a lot of different things that are quite similar to this, but it basically acts as the brains of this robot, and it has a sensor in it. So let me actually switch now to a different slide, and we're going to talk a little bit more about robots and what is a sensor and what is a motor, and like, you know, what makes this a robot? Because, you know, this robot here looks very, very different than this robot, right? Which also looks very different than the robots for FIRST. But I will play first a video of all the paper robots. Unfortunately, I couldn't set all of them up because, well, there's a lot of them and I only have so many electronics. So I usually have to take the electronics out of the paper. So most of those were robots. There were a few that I snuck in there that weren't actually robots. So let's actually talk what is a robot and why do these things made out of paper count as robots? So let's go to the beginning here. I realize that it shows all the answers if you kind of look. So let's view as a presentation. Okay. Also, I see questions coming in, so don't worry. At the end, we'll answer all the questions. So yeah. So first of all, like, what is a robot? So I don't know. Do you guys think this here is a robot? You can do a thumbs up or a thumbs down. Yeah, it's generally considered a robot. But how do I go to the next slide? There we go. Would you consider this to be a robot? I'm seeing some, not actually seeing all of you guys, seeing some thumbs up, some thumbs down. So I actually wouldn't count this as a robot, and I'll explain why in a moment. What about this washing machine? Mostly thumbs down. So that's the crazy part, is actually it can technically be a robot. So let's talk about what we actually define a robot as. So a robot is basically a machine that works automatically. So in other words, it doesn't need a human like me to give it instructions the entire time. Sometimes it only does some things automatically. Some things it does everything automatically. So the very first one, that's a really, really high-tech robot. That one probably does almost everything automatically. It doesn't need somebody controlling it from a computer, telling it what to do. The remote control car, on the other hand, if you're not controlling it with the remote, it doesn't do anything. So it's not doing anything automatically. It's just doing what the person says. The washing machine, that's where it kind of is. You wouldn't think of it as a robot. And a very simple washing machine where you have to push all the buttons and say, you know, I want it to run for this long and I want it to put this much detergent. That's not really doing anything automatically, right? Because you're giving it all these instructions. But actually, they now make washing machines that automatically decide how long they should run, how much detergent they put in, and they do this based on the weight of the clothes. So actually, they're kind of starting to think for themselves. They're doing things automatically because we don't have to give them all the instructions. And so at its basis, that's basically what a robot is, something that can do things automatically without all the instructions. So next question is, how are they doing things automatically? And if we actually, before we look at this, let me stop sharing for a second to show my robot again. So if we look at this guy again, it's very simple. It doesn't do very much, but what it does do is it does actually make some decisions automatically. So I mentioned this thing actually has some sensors built in. And so in this case, when I'm petting it, well, let me back up. So if I don't do anything, it's sitting there waiting for instructions. It's not doing anything. What it's actually waiting for is saying, is somebody petting me? And if the answer is no, it's going to say, okay, I'm not going to do anything then. And then if somebody does pet me, okay, I'm going to do something now. So it's making a very, very simple decision, but what it's doing is it's making a decision based on an input. And so an input is information it gets from the world outside. In this case, the information it gets from the world outside is somebody touching me? In this case, there's just a piece of aluminum foil there that it's actually looking for. Then it's making a decision about what to do. And that part is based on this, which is the computer, which is acting like its brain. So we have an input, which is how it gets information from outside. And then the output in this case is what it does to interact with the world around it. So in this case, it's using a motor, which you can't really see because it's inside of here, but you can see that little thing sticking out as part of a motor. Yeah, I glued that shut. And that would be the output. So if we look back at the slideshow, oh my, I have so many windows open that I can't figure out where it goes. Wrong one. Why does it keep showing the wrong video? I'm sorry, 1 second. There we go. This is what happens when you have too many windows open. Okay, so going back to this. So like I said, we have the input, the output, and the computer. And it actually is sort of similar to the way people work, right? Like for inputs, we have our 5 senses. We've got our sense of sight, our sense of smell, our sense of touch, taste, and hearing. Instead of a computer, we have a brain. Our brain makes these decisions for us. And for outputs, we have our muscles. So our muscles can move based on whatever decision we make. So for instance, if I'm like walking along and I see a wall in front of me, the input I'm getting is my eyes saying, oh, there's a wall in front of me. And it sends that message to the brain. And the brain says, there's a wall, what do I do? And so it makes a decision. And then it tells my muscles, okay, we're going to walk around the wall. So that's the way a human works. The way a robot works is really similar. So instead of, eyes and ears, it has electronic sensors. And so the sensors work very similarly to the way our senses work. The chip I showed you has a built-in like microphone that works as its ears. It has a built-in like touch sensor that works as its sense of touch, and actually you can shake it, so that's also another sense of touch. You can plug in something that can sense distance, so that can act as its eyes. And believe it or not, there are actually touch and smell sensors. They're not very it's not touch, sorry, taste and smell sensors. They're not very common, but they do exist. So those are some of the senses that robots have to work with. Instead of a brain, it has a computer. And depending on how complicated the robot is, it could be a very, very small computer. It could be a very big computer. It really depends on how many decisions it needs to make and how difficult those decisions are. And then for an output, instead of muscles, it has motors. And so, it can have a very simple little electrical powered motor. That sci-fi door I showed you used air power, which isn't technically a motor, but it's the same kind of idea of its, creating movement. So this is an example of a really complicated robot. And so this one, once it plays, has a lot of sensors. It's to basically be able to do all those movements and stuff. It needs to be able to have a lot of sensors to basically get as much input from the world as it can. It's got a big, complicated computer because it's making some really difficult decisions, and it's got a lot of different motors, so it can move in a lot of different ways. So that's an example of a much more high-tech robot. And actually that one's by Boston Dynamics. And, you can even see just on this part, all of those things are all cameras. And I'm not sure what that in the middle of there is, but that's probably also a sensor, or that might be to vent out air. I'm not actually sure. But the point is, like, this is, instead of like my little dragon, which can sense one thing and do one thing, this can do a whole bunch of things. And this is designed by a team of engineers, and they spend years working on this. So this is not quite something you can do at home, unless you put in, I guess, a lot of time. And I suppose if you do a bunch of research first. So, the robots I showed you earlier, they're sort of in between. So these robots do have more than one sensor, unlike the paper robots. So, this one needs to be able to sense, for instance, if there's someone in front of it, so it doesn't crash into them. It needs to sense, if it's under something as well, so it knows when to lift something up. And in terms of outputs, it can move around, it can lift things. It even has lights, which is a type of output. And similarly, even these ones, which are made by students, also have a lot of inputs and outputs. So the robots, by contrast, that I make at home are very basic. They're just usually one input, one output. Occasionally it's a couple more outputs if I'm moving two motors, or if I'm lighting something up or making a sound. And to go all the way back to engineers. So at the very beginning, I said, I'm a mechanical engineer. So I should say that there's actually a lot of different kinds of engineers who work on robots. So the software engineers, they're the programmers, and they write code, and basically they're writing the brains of the robot. They're working on the computer part. Electrical engineers, they're working on the electronics. So that's sort of like our nervous system. Like if you think about, all the wires and actually designing these sensors that they're using. And the mechanical engineers thinking about the body. So how is it actually going to move? How are you going to take, a motor, which just goes round and round, and make that into an arm that moves around? And also just thinking about, like, how are you going to make it so it doesn't break, and so it's strong enough to do everything it needs to do? So I guess let's make this a little more interactive now. And we'll also, again, we'll get to questions in a moment, but I kind of want to talk a little bit more about inputs and outputs, because for robotics, they're so important. So first of all, what are a human's 5 senses? I'm seeing answers in the chat. That's great. Sight, smell, touch, hearing. And we're missing one. Yeah, taste, exactly. So skin, that's a good one. That's actually part of touch. So our skin is like the main way that we feel things. So what are some of the senses of a robot? Yeah, so some robots can also see, and to do that, they can use different kinds of sensors. So they can use a sensor that actually has a camera on it. They can use an ultrasonic sensor, which actually works kind of like by echolocation. So it'll send out a sound, and it's waiting for the echo of it to come back. But that basically works as a sense of sight, because it can tell if there's something in front of it. Oh, I'm seeing a lot of great answers here. Light sensors, yep. So that's used to detect light, and the microbit I have actually has one of those built in. Sound sensors, so it's basically just a microphone, And so that's how it can listen for different kinds of sounds. You know, a very, very simple microphone might only listen to, is this loud or soft? A complicated microphone, like, you know, what you have in I don't know, a lot of smartphones actually can understand what you're saying. Contact sensors, so that's sort of like a sense of touch, and proximity and distance sensors. Again, they sort of work like sight. And I'm seeing some things here that are really cool, which is that robots also have some senses that we don't have. So somebody wrote soil moisture sensor. That's a great one. Like if I stick my hand in the soil, I can sense if it's, you know, wet or not, but I can't really sense like or measure exactly how wet it is. So that's an example of a sensor that a robot has that I don't. LiDAR is also using, is a type of like proximity sensor as well. So it's using, if I remember correctly, I think it's using lasers to like bounce things off objects as well. So an infrared sensor, again, that's another example of a sense that we don't have. So infrared is a kind of light that we don't see, but robots can actually see. And so robots can use infrared. First of all, they can like flash infrared to each other to kind of talk to each other. And they can also use it as a way to sense distance. So they can use it as sight as well. And UV sensors I'm seeing as well is ultraviolet, which is another kind of light that we can't see, but a robot can. Because, you know, we have our 5 senses, but robots actually have a lot of the same senses, or can have a lot of the same senses we have. And then some more. And as technology gets better and better, we'll probably even be able to make we'll be able to get more accurate sensors from there for sure. So like, again, there are actually smell and taste sensors for robots. They're not very common, but, you know, I'll bet in the future they will be. So what about outputs? What are humans' outputs? Talking, yep, that's an output. So that's a sound that I'm making to interact with the world. And just to remind you, so outputs are like how I interact with the world. Yeah, moving, limbs, body language. These are all good. Jumping. So yeah, excretion, that's true. So yeah, these are all basically how I interact with the world. And at the end of the day, what I'm really doing, even when I'm talking, I'm actually using my muscles for pretty much all of these things. So my main output as a human is moving my muscles to do something. And that could be moving my muscles to move my hands. It could be moving my vocal cords to make a sound. It could be moving my muscles to run away. So what are a robot's outputs? Like what, for instance, the dragon I showed before, what was the output there? Motor, yep. So the motor was the main output there, and it's moving its tail. And yeah, I'm seeing some other good things here. So talking, yeah. So there's robots that have audio and can make sound. LEDs, that's an output where they shine a light. So the chips are actually more of the brains of the robot. Mechanical arm, mechanical pump, these are all great examples. So robots have a lot of different outputs. A lot of them are usually based on some kind of motor, sometimes electronic motors, sometimes again using like air, which is called pneumatics, or even using water, which is called hydraulics. So those are all examples of things that robots can do. And so, you know, you can also combine motors to have more complicated movements, because like human movements are very complicated. And for a robot to imitate those, they'll usually need more motors. So we'll do one more exercise and then we'll go into questions. Yeah, gears I'm seeing. So gears are important as, so they're not an output in themselves, but they're a way to modify the movement of the robot. So you can use a gear actually to change movements. I actually have an example right here. So I'll stop sharing for a second here. So this is an example of a very simple gear here, made out of a cardboard and pizza box. And so that's a gear, rack and pinion. And what it does is it takes a turning motion, so just turning, and turns it into an up and down motion. And so you can imagine how I can attach a motor to this, and then my output, which is, you know, spinning, becomes up and down. And so gears are a way that you can use different mechanisms to kind of change the outputs. So if we go back to this, so let's say I am making a robot that needs to move around my house, and it needs to work even in the dark. It needs to not run into people or objects because I don't want it to, you know, ruin my house or hurt anybody. And it also needs to go up the stairs. So what are some of the inputs that we would want it to have? Inputs like, you know, what kind of sensors? Oops, sorry about that. Yeah, sight. So we would want it to be able to see if there's people. Sight, I'm seeing sight and night vision. I'm seeing hearing, yeah. So that way it can actually hear if there's people around as well. Touch, that's a really important one because it can actually tell if it's touching an object. Smell, so I don't know, would we, I mean, we could have a robot that goes and smells things. I don't know if we would need one for this kind of robot, but it would be really cool. Heat vision is actually also a sense of sight, basically. Taste, so it could taste. I think, you know, so as an engineer, sometimes you also have to make decisions about like what to include and what not to include, just because every sensor that I add is going to cost some money. So like if I need a robot that just needs to move around the house, but doesn't need to like taste things, I might not include that just because it would cost more money. So what kinds of decisions does it, oh, UV and infrared, so those are also sight. What kind of decisions does it need to make based on sight? Ooh, emotions, that would be cool. So in terms of decisions, like if the robot sees something, let's say it's driving through the kitchen and it sees a person in front of it, what decision does it need to make? Right, turn around or stop. So that's how it decides not to bump into things. Yeah, so we'll get back to the, yeah, climbing stairs. So how does it decide to climb the stairs? It would need to move a leg up. Yep, it needs to, first of all, decide I'm seeing stairs. So what kind of output would it have based on this? Like if it saw stairs or if it saw a person standing in front of it. Ooh, I'm seeing light there. That's a really good output, right? Because if it's in the dark and it turns on a light and it doesn't have night vision, well, now it can actually see things. A mechanism to help lift the robot, right? So that can be used to go up the stairs. Running, yeah, it can decide, oh, there's a person, I'm not going to go around. Sound, that's another good one. It could make a beep that warns you, hey, there's a robot right next to you, you know, careful not to trip on it. So what about hearing? What kind of decisions could it make based on its hearing? Yeah, changing direction of the wheels. So that would work. Talking, oh, that's cool. So that would actually be an output. So it could decide to talk. Listen to commands. That's basically a decision. You know, it could say, oh, I hear a sound. Now I'm going to listen to see if I'm getting instructions. Stop doing mechanisms. If it hears a loud noise, it might say, whoa, I'm going to stop in case that means there's somebody there. Right, not running into people. So the outputs we have are, for instance, talking. And then we said stopping. So, wow, we're getting a lot of really good ideas here. I'm sorry, I can't keep up with all of it. Brakes, yep, that's definitely an output. Scanning, so scanning kind of falls under sight, I guess, because there's a lot of different types of scanning. Yeah, stopping when it sees a person. This is all good. Yeah, camera, so that actually should go into sight. And then what about touch? What can it do based on the sense of touch? Like what kinds of decisions can it make if it feels that it's touching something? Examine. Oh, that's cool. So it could see what am I touching? Stop when it doesn't have enough fuel or charge. That's actually really good too. So that's almost a very different kinds of sensors. Feel people and objects. Right. So actually that kind of comes under inputs. But what would it do if it felt a person or an object? Yeah, it could tell the owner, it could scan the object, it can do all kinds of different things. Right. If it touches the stairs, then that can activate the stair walking mechanism. Could sacrifice itself. That seems a bit harsh. And yeah, to not run into anyone. So what are the outputs there? If it touches an object and it tells the owner, how is it telling the owner? It's talking, right? If it touches the stairs, what kind of output would it be then? I'll have to look at videos after. Sorry. Yeah, open wheels. Oop, I don't know how I accidentally made that tiny. Open wheels. Climb stairs. Or just climbing in general. We're not doing bombs either. Sorry. This is not a violent robot. This is the robot in my house that I don't want to blow up the house. Lift the parts using motor and gears. Right. Or yeah, it could stop. If it's touching something, it might say, whoa, I don't want to run into anything and hurt it. So that's just an example of like, brainstorming of how if I had to build a robot. Remember I said early on, if we go all the way back to the product design thing, I said a lot of it at the very beginning is actually brainstorming. So what we've been doing here is we've basically been brainstorming ideas for, if we had to build this robot, what are we going to make it look like? What sensors do we want it to have? So we're already thinking like engineers here. And we're actually, again, in some ways, that's robotics engineering, but it's also the same process that I used when I was doing product design as well. So I know this is a lot of things, but they all sort of actually tie together. So I think at this point, I will open it up to questions. Sharanya will will actually choose who's going to be asking, and we'll do it, I think, by unmuting people instead of just doing the chat.
Yeah. So anyone who has any questions that they would like to ask, if you could just raise your hand and then we can go one by one. Could you also please say your name before you ask your question?
Hello, my name is Arjun Signer, and I had one question. It was actually regarding, it was an old question, like basically, like if I don't like, this is simple. If there is this robot, if we wants it to do our own things, why do we need it has to go to other people if it's for our own personal use?
I guess it doesn't have to go to other people. So you can design a robot that does things automatically that actually can use, for instance, voice recognition. So you can have a robot that says, I'm only going to do something if I hear, your voice. If I hear a different voice, I'm not doing anything. So it's still making these decisions automatically, right? Because it's still deciding whose voice am I hearing? Is this the right voice that I'm hearing? If it is, then I'll do something. If it's not, I'm just going to ignore it.
Oh, okay. But then some people, some of them said talking. Means like talk to others?
It depends. So the cool thing about all this is it really depends on like what the engineer is trying to design. So there's robots that, you know, will talk to anyone. Like if you've used Siri or Google Voice, it talks to you. But what it really is sort of an engineer is told, you know, by a company or on their own decides, I want to make a robot that is going to talk to me and tell me to do things. It's all up to the engineer to decide, okay, what do I actually want it to say? What do I want it to do? And so it can be designed in, you know, however you want to design it, basically, within the limits of the technology we have.
And it's me both, sir. So actually, can you send me the instructions how to make an easy robotic paper Pikachu? You know, I love Pokemon actually.
Oh,
Actually, the Pikachu robot which you made is similar as the rabbit one which you made also.
I'm glad you noticed that actually, because so the bad news is neither of them work anymore because I had to take the motors out. Because I only have so many motors, so I have to reuse them. But you're right, they're basically the same body. So the bad news is I don't have instructions for the Pikachu, but the good news is I do have instructions for the rabbit. So I'll bet if you're creative, you can figure out, and I'm sure you're all very creative, you'll be able to figure out how you can take the instructions for the rabbit and make it into a Pikachu. So I can actually send the link, or I can send the link afterwards. You can send to everybody. Okay, we'll do that. So yeah, and if you make it, I would love to see it. And if you don't have motors, you can make it even without the motors, and then it's still, you know, a nice decoration you can have.
Ma'am, isn't paper a bad conductor of electricity? Then how does it move?
That's a really good question. Yes, you're right. So paper doesn't conduct electricity. What you can do though, and which can be a good thing and a bad thing, right? Because sometimes I don't want it to conduct electricity, is I can use something conductive on it. So for the dragon, it uses a piece of aluminum foil, tin foil. And because it's a metal, it does conduct electricity. So when I put it here, it doesn't do anything. And actually it's not plugged in right now, so it won't do anything anyway. But I'm accidentally touching the touchman. So if I touch it here, it doesn't do anything because you're right, the paper's not conductive. It's only when I touch it on the conductive part, it does something. And that's because the aluminum foil is conductive. So for the Pikachu and the rabbit, the secret there is that there's actually a very small piece of conductive tape, which it's basically a kind of tape that has some metal in it. And then on the back of this carrot, it has a little bit more. And so again, this doesn't have motors in it, but if it did, when I put that there, that closes the circuit. And so the conductive tape conducts the electricity. And based on that, you can even see more of the conductive tape there. That gets attached to the microbit and says, oh, I'm feeling something right now. So that's how it's actually conducting the electricity. It's not through the paper.
Is that just one robot who got citizenship of a country?
Sorry, what? Can you repeat that?
Is that just one robot who got citizenship of a country?
One robot that's the citizenship of a country?
Yeah.
I'm not sure I understand the question. So is the robot a citizen of the country?
No, I'm asking, is there just one robot who got citizenship of a country, or are there other robots as well?
Sorry, I'm still not following. So can you phrase the question in a different way, maybe?
I think what Rayansh is trying to ask is if there are any robots. So there is a robot called Sophia, which is a humanoid robot, which is a citizen of United Arab Emirates. So I think his question is, are there any other robots that have been created which are also recognized as citizens of countries?
I did not actually know she was a citizen, so I learned something new today. So thank you for teaching me that. I have no idea.
Yeah. So I think it was back in 2017 that Sophia was made a citizen of Saudi Arabia.
Wow. That is very interesting because they usually don't make like robots or things that aren't humans into citizens. So yeah, that's yeah, I don't know if there are any others.
All right. I think Daksh also has a question. Daksh, you can unmute and ask.
Ma'am, suppose the chip of the robot malfunctions, then how will the engineer fix that robot?
If the shape of the robot doesn't function, you said?
He said if the chip starts to malfunction, like the
Oh, the
computer
chip
bit of the
can-
robot. what
Yeah,
happens?
so that's actually the sort of thing that an electrical engineer deals with. So they're the ones who design like the actual chip part of it. And if it malfunctions, you know, it really depends. Like if it's a very complicated computer part that can be fixed, they might want to fix the chip instead of replacing the whole thing because it might be very expensive. If it's something very simple, and you know, it might be cheaper to just put a new one, but it also just depends on how it malfunctions. So if it malfunctions, if you, for instance, put too much electricity through the chip by accident, it can actually melt parts on the chip. In that case, you would have to probably replace those parts that melted because they won't work anymore. A lot of the times though, the malfunctions usually aren't on the chip. It's usually something like in the software, like you programmed it to do something that you said I wanted the tail to move, but what you might have actually programmed was a little bit different. So before checking the chip, the first thing I would probably check would be the software. And sometimes it's actually the mechanical part. So usually those are more likely to fail than the chips themselves. But yeah, it really depends. Like that's something that an electronics engineer would know in more detail about, like, okay, when is it worth getting a new part? When is it worth fixing the part you already have? How did it actually malfunction? Is it something that can be fixed, or is it something that needs to be replaced?
All right. I think Pranav also has a question. Pranav, could you unmute and ask?
I've posted it in the chat.
Okay, I will look in the chat. Sorry, there's also construction outside. I don't know if you guys can hear it. Is this the video link or is this a question that I'm seeing in the chat? Okay, so I'll watch the video afterwards. I think just because I don't know if people really want to sit here and watch me watch a video. But I promise I will actually open the link.
I got one more question in the chat, I think from Rehan, that if he also wants to become a robot engineer, what should he do?
Oh, that's a really good question. So I think the main things are, first of all, you know, so I should say it depends what kind of robotics engineer, because again, there's, you know, software engineers, there's electronics engineers, there's mechanical engineers. Either way, it really helps to, you know, put in a lot of effort in your math and science classes, because a lot of those principles get used with robotics. And even if you're not excited about math, like that's okay, actually. A lot of the times it's more of the way of thinking, trying to think logically. And then when you finish, you know, high school and if you're looking to go to college, you can actually look for engineering courses that focus on robotics. But I just want to say also, because like, you know, I think there's this idea of like, oh no, like, but what if I don't like math, or what if I didn't study the right degree? So I actually have a friend who makes robots, who went to art school. And after art school, he actually decided he wasn't that interested in just art and taught himself robotics. So a lot of the stuff you can actually, you know, if it's something you're interested in, you can teach it yourself by just starting to try things. And so if you can, especially if your school has any of the basic parts, like a microbit or something, you can actually start practicing programming on your own. You can start practicing building things. Like, again, I make things even just out of paper and cardboard, and you can practice mechanisms that way. So there's a lot of different routes into robotics. But yeah, I'd say the best thing is, in school, just focus on the things you love and try and do your best in science and math, and those will really help you.
Okay. Are there any other questions? Because I can't see anybody's hand up.
And I've opened the video, so I promise I'll watch it afterwards. I see it's a Boston Dynamics and Hyundai video. Oh, and BTS. Wow, okay. I'm betting it's one of the dancing robots, isn't it?
All right. I think we don't have any more questions for now. Thank you so much, everyone, for coming. Thank you so much to Ms. Jasmine for taking out the time to do this for us, to interact with all of the students here. Thank you so much for joining us today. And for all of the students on this call, there's a link in the chat box for a feedback form. It would be great if all of you could please fill that out. And once you're done filling that, feel free to drop off. If you have any more questions, please, you can just write them in the chat.
And I'll send the link to make the bunny robot. And actually there's links for instructions for some of the others. So if you want to try them, definitely go for it. And if you want to put your own creative spin on it, like I'd love